Okay, so this morning, we've had a couple days of um, weather related stuff, and this is the first day, back in the classroom. Um, had a couple questions, where are the videos? Where the due dates are weird, and so yes, all that. Um, I'm putting things in the weeks, so this is week 1 of the course. Next week is week 2. Next week is week 3. The week after that, week 3, and so on and so forth. And so, um, you need to be looking in week 1 folder. And in week 1 folder, there will be resources in there. And yes, I've also put videos from prior classes in there also. So that gives you it gives you content. Don't skip it because it has an old date. It's the same material in the course. The course is very specific as to what we cover in the course. So if you're online, you have the same material that people in the class get. But there just happens to be 2 different versions. You can watch either one. I should be delivering pretty much the same material in each video. There is an initial quiz, and I've set the due date on it. Everybody needs to go do that. And there's 3 packet tracer assignments that are due. And there's a link here that says shortcuts to complete packet tracers. That is a video, and then shortcuts for packet tracers and screenshots. So this tells you how to take screenshots, which is what I want to do, what I want you to do for packet tracers. And there's a video on how to do that. That's my video on YouTube, how to do packet tracers. So if you're not watching those, this clock hex is not correct. Okay. And so you need to watch the videos. Now, yesterday I didn't, for whatever reason, I didn't get the video recorded, but I am recording today. We went through the first module and some of the slides in the first module, and basically we're doing the first 3 modules in this first week. That is based on the course schedule. And the course schedule is going to be right here, course overview. So week 1, this is the 3 modules: basic network connectivity and communications. So I can't say, well, we had 2 snow days, so we don't have to do that material. It's still there, and we have to work through it. So let's see. I took the slides in the first 3 modules, and I first 2 anyway, and I pared them down a little bit. And yesterday I showed some components in the slideshow. So hold on one sec. I'm going to pull that up. Okay, so we're gonna look in the PowerPoints folder, and there's the PowerPoint for module 1. And I want to show you some key things in these PowerPoints that are here. Let's see. You may have to download them. Now, if you download the file, there's some hidden slides in the first part of it. They give you other information about the slideshow and about some things that are inside there. So it's kind of a good thing to look at. Another thing is at the end, there are summary slides. What did I learn in this module? So these are good things to read real quick. You can get a summary of the slideshow of the module. And you can see what is in there. So I would always start with this. Go and read this summary. And that way you're ready to look at the module. And then let's see. Yeah, if you download it, there's some other stuff in here. Let me look at module 2. So if I go to module 2, let me scroll down to the bottom. What did I learn in this module? Read this summary. And then, yeah, if you download it, there's some more material here on the end that is a list of commands and new terms that are found in these modules. Let me see if I can get them real quick. Let's see. I don't know why this didn't want to work. Okay, settings. Internet. Options. 30. No, one. Okay, so it's not allowing me to download this file. Let's see. Um, all right, I'm gonna get it right here. Okay, so here's the second module, and I'm gonna load this up in PowerPoint. Because there's some extra stuff in here. For one thing, there's an index that shows you what slides have what content. So that's a good thing to have available. The other thing is not only the what did I learn in this module summaries, but new terms and commands. So these slides are very informative. So one thing that I would recommend doing is copying that slide and make your own PowerPoint deck, and just go ahead and paste in that those slides like that. That will give you some will give you a guide with someone had asked me yesterday, is there a list of all the commands? This gives a lot of the key words that are introduced in those modules. So it's a really good study tool to see what's there. So if there's something that's unfamiliar to you in this list, you know which module to look at to find the answer. So these are really good resources. Okay. So my PowerPoint did not actually pull over this morning, so I'm going to use I'm going to use the PowerPoint from module 2. Let's see. No, I'm going to go back to module 1 real quick, and let's see. So we talked about internetworking devices yesterday and a little bit on Tuesday. We talked about topologies. I showed the packet tracer environment and what the topology looks like. I showed that on Tuesday and Wednesday. Uh, So we start looking at basically what happens, why we want to have connectivity or between devices and networks, and we want to do what's called reliability. So it's important that our communications that we make are able to be delivered to the destination. So whenever I make a communication, I do so in the anticipation that it's going to reach its destination. I don't make a communication because I think it's going to fail. And so the way I create my network is what we're going to really study when we delve into the network itself and go, okay, well, what's the device in there that makes that communication reliable? And so we have intermediary devices between our computers, our PCs, and our servers um, that um, that actually work to deliver that traffic. And in between is our physical hardware. And so this component right here in the middle of these machines is the switch. And so when you look at a switch, effectively this switch becomes the heart of the network system. And so before we had intelligent switches and configurable switches, we just merely had things called hubs. And hubs were pretty much, it was a port, and all the ports were wired together, and you plug the devices in. There was a situation where there could be collisions between those um, devices, and it was a real struggle to communicate because what is inside here in this wire is any number of single wires that can communicate both a signal that's sent or received. In an early network where a computer was connected to the next one, there was only 2 wires. And there was a cable called a twin-ax cable, which was basically 2 wires that were running through the connector, and they were twisted. And that was this send and receive of the connection. And so the ring on that was a ground. Let me see if I can show you that picture. Yeah. So this is kind of what that, no, that's a modern twin X cable. Let's see. So back in the early days, the cable looked like this, and there was two pins. And so all of the connections went through this. When I hooked this up to the server or to the terminal, basically the everything that was going into the display came down this wire, and everything that was coming from the terminal came down this wire back to the main control. And so we started out with two wires, and this was a basically each wire um, handled the communications, and there was a box that switched uh, each particular connection in turn. Um, and so that was basically the way that the communication worked. And these are very heavy cables, very industrial, not at all like what we would see in our current Ethernet implementation. There's been a lot of technology changes in the actual network media since the early days. Let's see. I don't know. It's even hard to find pictures of these devices now. Let's see. Okay. So the next iteration after TwinX, I get to what's called a MAL. This is an original token ring network. And so this particular switch worked in that as this device would read the wire here, and then it would read the wire here, and then it would read the wire here, and it would go in order. And everywhere there was a cable plugged in, it would read that particular device in turn, and it would just go through the whole sequence and read each wire and look for a presence or the absence of a signal. And so I would hook up, 1, 2, 3, 4, 5, 6, 7, 8. I guess there's probably 9 spots here, and I could have 9 computers plugged into this switch. And so each particular packet that was plugged in would have an address that would allow it to be delivered to the right place. And this was an early form of communication. It was called token ring, and we'll learn about the token ring implementation. But these are very industrial. They're very heavy. They're very expensive to implement. The cables are expensive. But these were early switch networks that were produced. And so it was very slow. And so we changed the way we've done networking a lot since those days. But we're still doing it for the same reason, and that is because we need to communicate with somebody else. Whether it's sharing information about the way our computers function or whether we're sending data over email or however we do it. We got to have something in the middle to make that connection work. And then we have to have this other device here called a router. And a router is another intermediary device. And it is designed simply to take a packet of information to look at its destination and decide where to send it. It has a very limited amount of work in what it does. So the real brains of the network is the switch, actually, which is counterintuitive. We don't normally think of the switch being the workhorse of the network, but it certainly is the most important part. So the interesting thing here, packet switching splits traffic into packets that are routed over a network. Each packet could theoretically take a different path to the destination. And that's exactly what happens when it encounters a router. Is at that particular time, that packet is looked at and it is decided whether or not it should continue on its path or which path it should take. And that's the basis of the network. The switch effectively it doesn't do any routing. It is at a different layer of communications than the routers. But it does have addresses that it uses to deliver packets. Okay. We looked at topology yesterday, and so there's an assignment in the course, and I think I put it in week 2 of creating a logical and a physical topology. And the topology is a network layout. So let's see. Two. Well, let's see. I'm not sure where that slide is. Let's see. Okay, so let me go into Packet Tracer real quick, and I'll show you that. Packet Tracer. Again, this is their software we're going to use. To do network layouts. Generally, when you download the Packet Tracer from the Blackboard or from the Netacad, the file is going to come pre-made with some things in it. Okay. All right. So here we have a blank canvas, and this is our logical topology. So when we have a logical topology, what we are talking about is we're talking about the way that the network flows. So I'm going to put a router on the canvas, and I'm going to say that this is the place where my data would enter my network, and it would also be the place where my data would exit my network. And we're going to learn that this has a name, and it has the name of a gateway interface. So this is where the network would be terminated. And then we get to the intermediary device of a switch. And the switch is where multiple computers would connect to. And I'm going to put in CPCs right here. These are our end devices, otherwise known as our hosts. And so this represents a wireless user, a laptop user, someone who is using the network to gain access to some network resources. Okay, and we're going to use a straight through cable. And I click on that, and now I get a list of ports, and I get to choose what port I want to plug it into. I'm just going to plug it into the first one. And now I click on that one, and I get the, let's see, I got to click on the cable again. I'm going to choose the copper straight through. I choose the Ethernet port and plug this cable into the other Ethernet port. Okay. Between the switch and the router, you'll notice two other ports down here that are different. These are gigabit interfaces. This indicates the speed of the interface. So it's faster. And I'll connect it to a similar interface on the router. But what I'm doing here is I am actually creating a logical topology of a network. And I'm looking at the fact that when information enters into this network, it hits the switch and it flows toward the end device. And when it wants to leave the network, it emanates from that end device, hits the switch, goes up to the router, and exits the network. So that's my logical topology. Okay, physical is this other concept that looks at an actual place. It's tied to a geographic location. It's tied to a building. And there is a room inside this building where there is a rack with some equipment in it. Okay. And then right here, I'm going to click on the navigation panel, and I can drag my PCs into my wiring closet. and then automatically sticks them on the table. And so now I have a physical, this is my physical topology. So if I wanted to say, okay, this is my physical topology, I'm going to go ahead and take a screenshot, Windows key Shift S. Right, and there's my physical layout. Now I'll go ahead and make a new closet. And I'm going to go ahead and put some stuff in here. I'm going to make a new rack, new table, new shelf, put a pegboard in there. I'll put some cables up on the pegboard. Put another router in the rack. Put some switches in there. Now, I'm getting to really choose my physical layout. Of these devices. I'm putting them right where I want them in my server room. And that's what would happen, if I was doing this in real life, I would be putting these things into a rack and I would be bolting them in there. But when I cable them up, that's when when I'm actually connecting them with wires, that's when I'm building my logical diagram. So over here, I just have these devices that are free to be moved around on my logical diagram. And because I don't have any cables hooked up, I don't really know how they're wired together. Okay. So I might decide that I have 3 classrooms worth of computers, and I need to put a switch in each room. To handle all those machines. And this router is going to connect my 2 networks together. And so when I look at that, I'm actually able to see the front and the back of this device. And what I can see is that it doesn't have any, it has some space for some other modules in there, right? So if I wanted to hook that up between if I wanted to hook those routers up together, I might need to add some expanded ports to make that work. And then right here, I have some USB ports. I have a Ethernet interface. I have a console port, and I have an auxiliary port. What we will find is that when we start looking at the way these are configured is that these particular ports have interfaces associated with them, and they're able to do certain things. So, for example, this console port right here gives me a very specific set of privileges. One that I can, if I plug into it, I have the ability to see without any passwords or anything. It will show me the configuration of the router, and I'm able to communicate with it on a whole different level, right? I get to see what's there. What I get is what's in the CLI tab right here. And so this would all be output to my terminal emulation software. And so I'm going to show you what that looks like. I'm going to take a PC, which I have connected right here. And I'm going to take this cable, which is called a console cable. And I'm going to choose the PC and look for RS-232. All right. Now I have a blue console cable plugged into my RS-232 port. And I'm going to go over here. First of all, this switch. And I'm going to plug that into the console port right there. Because what I want to do is directly configure this thing. So this, so when I look at my computer and I look at the desktop, okay, this is my simulation for all the different desktop apps that I would normally have on the machine, for example. And I have a command prompt, like a DOS shell. So I could list files and folders. I could use help. I could use Python, right? I could use SSH, right? There's a whole simulation here on this PC. And so I'm going to go back to my desktop here effectively. I'm going to click on my terminal emulator. And I just click OK. Now what's happening is when I use this terminal emulator, is I am actually utilizing the communication port that's going through that serial connection. And these settings you don't have to change. But essentially what this is doing is it's telling the computer how to interpret the signals that it receives. It tells it how many bits are in a byte, how to understand those things, how to start and stop communications. But these are the rules that we're going to use to communicate by. So while I could change them and make them work differently, in this case, these settings are the way they need to be. And I click OK. And so now, effectively what has happened is I have initiated the communication with this switch, and I get to see the boot up process. So I'm going to just type in, let's see. Shifts. Okay. I'm going to watch it reboot. I'm going to use the command reload. And it's actually loading the operating system software here. Now, in real life, when we look at one of these switches, they take a long time to start up. They have to go through and do all the internal hardware checks, all of the port checks. They have to cycle through every single port. It takes quite a while to start up the switch from a cold state. But eventually what happens is we get this message. So it's done hardware checks. We've gotten some information about the software. We got a license agreement. We see information about when the software was compiled. We do a file system check. And then we start looking at flash. And the flash is actually where the configurations are stored. And it begins to read that whole configuration and give us some information about the system. So effectively what happens now is this particular switch is ready to start operation as a switch. And it doesn't have to, necessarily do much at this point. So once that switch loads its configuration, it is in the process of switching data between hosts. And so that's basically a lot of times all you'll see there. Now, you may go in and need to configure it. We'll look at, let's see, if I go in here. Now, what I have here is I am looking at the outside of the operating system. This is known as the command line interface, CLI. And so I have a direct line into the inside, but I can't really ever get there into the operating system. So this is as close as I can get, and it's the CLI, and it's also called an interpreter. Okay. So the CLI is a command line interface. and it acts as an interpreter. So that's what you need to know there is that there is a piece of software in between you and the actual operating system of the switch, otherwise known as the kernel. Okay. The kernel is in the center. And so what's running inside there is the iOS system, or the internal operating system. Okay, it's called iOS. That's the name of it. But Cisco iOS and Apple iOS are different. But there's an internal operating system running inside, and the command line interface acts as an interpreter to interpret whatever you type on this line. And so that's why we look at that prompt and it says switch. It's a completely default. There's no name to it. The name of the switch is switch. But we haven't actually set anything up yet. But I'm going to give it a command. All right, and that command is going to be the question mark. And when I do the question mark, I get some help. So I'm going to put in I'm going to make this bigger so we can see it. These are the commands that are in user mode, okay, which is where I'm at right now on my switch. I'm in user mode. And user mode is the lowest form of security that I can get. I've gotten through the communications. It didn't ask me for a password, and it's given me these are the commands that I can do. So basically I can go back and forth between the privilege mode, enable and disable. Exit and log out. That's the exec mode, right? So when I turn on enable, I'm going to be able to move into that next level of the environment and do some more stuff. And both of these commands will get me out of it. The other thing that I can do is I can have this switch send some messages out for me. I can do some pings. And I can open some network connections. And then I have a trace route. So a ping and a trace route are really similar. And then I can do some show commands. So a show will give me more information. So if I do show, let's see, show, and a question mark. These are all the show commands I can do. So if I were to want to look at the interfaces, I could show that. I could see information about each one of those ports. I could show IP address information. I can look at the MAC address table of the devices that are connected to my switch. Most of your switches in your home routers. So in your home wireless router that you have, let me show a picture of that. So maybe I have something in my house that looks like this. We got some antennas on it. Look for one. Okay, so maybe it has something on the back, right? These are switch ports. The yellow ones are switch ports. And the blue one is a router port. So in this particular case, this device combines a very small switch with a very small router into one device. So these are my switch ports, and that's where my router interface goes. It looks like I have some other thing right here. I don't know what that is. Maybe another backup internet connection, I'm not sure. Okay. So in this enterprise networks, we don't combine them together necessarily. We separate them apart. So in this case, this particular switch has 4, 8, 16. What is that? Is that 8, 16, 24, 32? Let's see, 4, 8, 16, 24, 48 ports. So these are 48 ports of access ports where I could plug in 48 PCs. And then these ports right here are uplink ports. They're stacking ports. So I can hook up multiple switches together. So let's say that I put this in my wiring closet and I had 100 PCs that I wanted to connect in. I would stack 2 of these switches together. I would plug in all the PCs into those 2 switches. Now the problem is that if one of these switches were to die, I would lose connectivity to 100 devices. So it's not very reliable. It's not very resilient. It may be plenty reliable because maybe they have dual power supplies and who knows what else. But there's a good chance of failure if I have that much going on. Okay. Hector wants to know if we want to buy something. No, we don't. We're good. Okay. Don't want to buy anything from Hector right now. Okay. But so different models of switches are going to have different commands available because they may or may not have those particular modules available. Like in this particular case, this command has a show command, and it has a multi-layer switching information. Now, not all switches have multi-layer. They just have interfaces only, and so the commands are going to be based on what the switches have on them. So we can go to window, and let's see, here's my, if this doesn't come up, I'm kind of showing you how to use the software too. So if this is in the way, you can go up to window, and there's my communications with my device. So let's just do show interfaces. And now this is going to give me information about each interface. So I'm going to copy it, and we're going to look at it. So if you just read one of these, it actually tells you quite a bit about it. That is Fast Ethernet 01 is the interface's name. But it also tells you about its speed. So if it's fast Ethernet, that means that it's up to 100 megabits per second. And then we have the interface number, 0/1. We can see that it's up, which means it's operational. The protocol on the line is up. It has something connected to it. It has a hardware address. And if we see these hardware addresses, this is called our MAC address. And I'm just showing you this so you'll know, because this is going to be information that we'll learn in a course. But there's another way to show this MAC address, and it's a totally different notation. This is the standard notation that you'll see in most of the documentation and books. And this is the Cisco notation. So if we look at it in terms of bytes, I'm going to count bytes. So 1, 2, 3, 4, 5, 6. Those are bytes. So each one of those digits makes a byte. Sorry, every two of those digits makes a byte. And so that's 2 bytes, 4 bytes, 6 bytes. The only difference in these two addresses is the notation that we use. But this is called the MAC address. Okay, and every single interface that is created, every single physical port that's created has a globally unique MAC address. Interfaces sometimes don't because they could reuse MAC addresses, but hardware ports have globally unique MAC addresses that they use. We count the bytes: 1, 2, 3, 4, 5, 6. 2 bytes, 4 bytes, 6 bytes. Okay. That one right there is a half byte. And it's called a nibble. Okay, and that is 1 half byte. Otherwise, it is 4 bits. Right, so those are some things you want to memorize. You want to memorize bytes and bits. And this word MAC address. Okay, we'll keep looking through our output here. So our address of our port, 6 bytes, 246, is our bandwidth. 100,000 kilobits. Otherwise known as 100 megabits. Delay, 1,000 picoseconds. Or maybe that's microseconds. Yeah. And this is the reliability number, right? It's maxed out. There's nothing there to know. Sometimes that'll change, but let me look at full duplex. This is telling us the type of communication it is, that we can both send and receive. And it's 100 megabits per second. So if I take the 100 and I multiply by 1,000 kilobytes per megabyte, I get 100,000 up here. Okay. 100 megabits per second. And this gives me information. When was the last time I received something from it? The last time I cleared the counters. My queues. How I'm doing queues. Over the last 5 minutes, how much have I received? Over the last 5 minutes, how much have I sent? Right, it just keeps on going. So lots of information statistically is collected through this interface. So if I were to see if I were to look at something and go, man, I'm getting some really weird stuff going on this network, I might just want to look and see if there's some errors, if there's some collisions, if there's been some resets, right? So I can get some ideas of maybe what's going on here if we have some weird stuff going on. So these statistics can be very helpful. And so one of the things that happens is that as these switches are in operation, the switch will be able to communicate the information from these counters and statistics to all kinds of devices, and those get logged and we get a lot of information out of it. So each particular switch has those on every single port. So that is, again, that was the show command and the interfaces. And every interface that I have has that information. And what I'm doing here is on this interface is I'm actually using my space bar to page through. And if I decide I don't want any more, I can type Q to get out of it, Q to quit. And then I back up my command prompt. So one thing I want you to do over the weekend is download Packet Tracer, open it up, put some stuff in the interface, practice connecting the cables, put the PC there, connect the console cable, log in, and start playing around with this switch. And look at the commands. See how the CLI works. Use the question mark to help. Use your show command, and you can put a show and a space and a question mark to get more commands. And if you press enter too soon, you can press up and keep pressing question mark and see what else it wants. Okay. All right. And there's also some packet tracers in the week. You want to download the packet tracer, and it will show you how to complete that assignment.